Alright, let's take a look at getting ready 3.7. So, kind of going over some similar stuff that we've already been doing. Remember, when we're trying to find constant ratio, that means it's geometric, means we're timesing by the same number. Well, how do we go from 2 to 4, 4 to 8, 8 to 16? Well, we're doubling. In other words, we're timesing by 2 each time. So, that's our constant ratio. If we look at number 3, we've got negative 5 to 10. 10 to negative 20. We know these are geometric, so how can we go from 5 to 10? Well, we're timesing by 2. That gets us to 10 to 20, 20 to 40. But how do we go from negative to a positive? We times by a negative 2. Okay, so we're multiplying by a negative 2 on this one. That takes us from positive to negative to positive and back. So that's all we got to deal with on those ones. Okay, now, recursive and explicit equations. Remember, if it's arithmetic, you're using slope-intercept form, y equals mx plus b. If it's a geometric, you're using y equals a times b to the x, the exponential version. Okay, so let's take a look at ours. Well, 5 to 7, 7 to 9, we're adding 2 each time, right? Well, let's not write it right there. Let's write it over here. Adding 2 each time. So we'd go 11 and 13. So for our recursive, we're saying to get to the next term, it's equal to the previous term, n minus 1, and we're just adding 2. And what was our first term of our function? It was 5. So that gives us the starting point. For the explicit, remember, so we're adding, so that means it's arithmetic. We are going with the slope-intercept form. So we need the slope, which the way we get the slope, how is the y growing? We're adding 2. Slope is y over x, so the adding 2, positive 2 over x, over the positive 2 for the y, okay? That's all I'm saying. And then we're adding 1 on the x, so how do we simplify that? 2 over 1 is just 2. Then our y-intercept, we have to go back 1. Okay, we want to know when x is 0, what is y? Well, going backwards, it would be 3. So our y-intercept is 3. So we either go y equals 2x plus 3, or if we're trying to keep this same notation, we would go f of n equals 2n plus 3. Same thing. Okay, so that's all we got to do on those types. Now, this one's a table, so it's kind of the same idea. How is it growing? Well, 3 to 9 is adding 6. Can we add 6 to get that? Nope. What else can we do? Well, 3 times 3 gives us 9 times 3. Does that give us 27? Yep, times 3, that gives us 81. Times 3, that gives us 243. Okay, so this one's geometric, which means we're using, for the explicit, y equals a times b to the x. Okay, but first let's do recursive. Recursive, we're saying the next term is equal to the previous term. Okay, the n just means what term number we're talking about. So if I'm talking about term 3, the n would be 3. What would be f of n minus 1? It would have the 2 in there, so it would be 9. And all we do is times that by 3. And what is our starting point? Well, that first term is actually 3. Now, the explicit, the A stands for the y-intercept, the B for the growth. Well, how is this growing? We're timesing by 3 each time. So B equals 3. What's our y-intercept? Well, we've got to go back to where x is 0. And what is y? Well, what's the opposite of timesing by 3? Dividing by 3. 3 divided by 3 is 1. Because 1 times 3 would give us 3. So A is 1. So we could write y equals 1 times 3 to the x, or f of n, that's like the y, equals 1 times 3 to the n. N would be like the x. Okay? So there we go. You probably have some more types like that. Now, on this go, we're just graphing and labeling our windows. Okay, so just graph your equation, and you'll have to make it, some sort of graph here. Go like this. And I'd probably say, 1, 2, 3, 4, 5, 6. So I'd be going up to 6. 1, 2, 3, 4, 5, 6, down to negative 6. And to the right, 1, 2, 3, 4, 5, 6, 7, 8, go 8, 2, 3, 4, 5, 6, 7, 8, 9, 10. Apparently I decided to go to negative 10. So that's what it means by labeling our window, making sure we know what we're looking at. So, slope-intercept form, y-intercept is 5, go up to 5. My slope, down 3 to the right 4. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. So my graph would look something like this. Okay? Now in 16, that's in the standard form. We could do two things. You can graph a standard form by making the x equal to 0 and the y equal to 0 and find an x and y intercepts. Okay, that would work. Or you could just solve it for y to get the slope-intercept form. Either way works. For this today's stuff, I'm going to solve it by y. So first I subtracted the x's from both sides, left me with just a negative 3y. Then I'm going to divide by negative 3 to everything. That just leaves me with y. Negative 1x over negative 3 is 1/3 x. Negative positive 7 over negative 3, well, a few different ways I could write that. I'll just say it's a negative 2 and 1/3, or 2.3. Okay? So same idea. Draw my graph. Our y-intercept is a negative 1, 2, in here somewhere. So put it right about there. Okay. Then our slope, we're going up 1 and to the right 3. So we go up 1 to the right 3. So we're out right there. Up 1 to the right 3, about right there. Up 1 to the right 3, about right there. And it's tough. Something like that. Close enough for me. And label this, well, I went out to 9. On the back side, I honestly didn't need to go very far. We'll say to 7. Down here, went down to negative 4 up here, up to positive 4. That works. Okay, so there we go. Hopefully this one's not too bad. Just make sure you guys are getting this stuff done and getting ready.